Okay, so what's your question?
Are you have confidence intervals on this test?
Yeah, we will have confidence intervals on this test. It'll be very similar to your last test, only hopefully not as long. Because that last test was way too long.
Can we go over them? Because I'm not sure that I really.
Okay. Can we go over them?
Well, if we do an example, and also maybe we can do an example.
So here, let me just say this, okay? This came up in my other class. I've already posted the video. It's already up there. Somebody asked me about a confidence interval for 2 population standard deviations. If you look on your formula sheet here, there is no, oh, anyway, it's on the video. Even if you can't see it. If you look on your thing here, there's no confidence interval for 2 population standard deviations. Okay, now, having said that, if I ask you for that, don't leave it blank. If you leave it blank, I'm going to think you didn't know. If you say there is no confidence interval, then I'll give you credit. Okay, so there's not confidence intervals for everything. So you have your formula sheet here. Don't make up a confidence interval when it doesn't exist. Okay, I'm going to assume that you know when they exist and when they don't. But I just gave that one to you. So F doesn't exist. There could be others. But I know that one because that's what we talked about, the video that's already posted online, that I'm sure Glenn is watching right now. But hopefully he's not driving.
He's not in his car yet.
He's not in his car yet. But he'll be watching it when he hears this, he'll be watching it.
Can we do something where, like, when we practice confidence interval, just one, and also.
Say it again?
Can we do an example where we practice confidence interval and also where we practice a QQ plot? It's been a minute.
You'll do a QQ plot? Okay, there won't be a QQ plot on this test, but it will be on the final.
Okay, well, then let's not do the QQ plot right now.
Okay, let's not
On
do
the computer test, there won't be one?
not on this test, but there likely will be on the final. Because right now we've been skipping all those QQ plots, but I won't do that on the final. I'll be like, okay, do it. Okay, I'll make you do all the steps, no skipping. So you want me to do what?
A confidence interval?
Just pick one?
Yeah, just something that has.
Which one do you not know? Because it's hard for me to come up with these. Do you want me to do an F?
No, maybe a chi.
Chi-square confidence intervals for like 1 standard deviation, or they can't do the 2. It doesn't exist.
For like the independence test then.
Which independence test?
Chi-square.
Chi-square independence test, there's no confidence interval.
A T.
Okay, so that's an important thing. If I give you one on the test, don't do it. Just say that it doesn't exist. Because I don't want to give it away, because somebody's going to do it, think it's a 2 proportion test, and they'll do one. Actually, you could do, I have told you this, right? If you have a two proportion test or a chi-square independence test for 2 proportions, actually you could find one in that case. But I would recommend that you treated that as a 2 proportion test, not as a chi-square independence test. However, if you did it as a chi-square independence test, your p-value will be exactly the same as a 2 proportion test. So that's the one case where it doesn't really matter which one you do. It will when you do the confidence interval, because the confidence interval won't exist for the independence, but it will exist for the 2 proportion test. Okay, did I confuse you enough there?
Yeah. Can you just say it one more time? Which one?
Do you want to do a 2 proportion test? Should we do one? Because you can do a confidence interval on that. Okay, so let me pick a 2. See, the problem is when you say pick one, then it takes away some of the intrigue. Okay, so I'm going to pick, but if that's what you want to do. So just a reminder, I already did the two standard deviation F tests on the other video, so check that out. Well, before tomorrow, if you want to know it by tomorrow. Or before today, if you're taking it today. Okay, so here we go. 2 proportions. The Iraq War. Here we go. This is problem 27 on page 541. In March 2003, Pew research asked 1,508 adult Americans, do you believe U.S. made right or wrong decision to use military force in Iraq? (1086) said yes. In August 2010,
Said yes to what?
said yeah, that's yeah. Oh, said it made the right decision. Yeah, said yeah, you're right. That was confusing. Said right decision. In August 2010, Pew asked same question to 1,508. I can't believe they got the same number. That's kind of weird. And found 618 said right decision. Okay, so I'm going to do it. Well, this question says find 90% confidence interval. So that was your first question. We'll just do that. We could also do a hypothesis test. Okay, and so we'll call that part A. Find a 90% confidence interval. Part B says do hypothesis test with alpha equal to 0.01. Now, should those agree or disagree, or who knows? Who says those should agree before we even do any math? Those should agree. Who says those should disagree? Who says I don't know if they should agree or disagree? That's actually the right answer. We haven't done the test yet. Okay? They could agree, they could disagree. Okay? Why? If they disagreed, why would they disagree?
Because if they disagree, then the p-value would not be.
P-value would not be within the 90%. You're kind of on the right track, but that's not what I was looking for. If they disagree, the most likely reason would be because your alphas are different. One's got an alpha of 0.01, the other one's got an alpha of 0.10. So this could be a case where they disagree, but the main reason is because you don't have the same alpha. So you could do them both correctly and have them disagree. If you use the same alpha, 99% of the time or more, you should get the same conclusion. Okay? But I purposely did these with a different alpha so that they might agree or they might disagree, and I don't know. Okay? But to answer Caitlin's question, let's do the 90% confidence interval. That's actually going to take a lot less time. How would you do that? Oh, am I sharing? I'm not sharing. Let's share so now people can see. Confidence interval for two proportions. So the equation is, okay, the equation that you should use is what? P1 hat minus P2 hat minus, plus or minus, right? Z sub alpha over 2 times square root of P1 hat. I'm going to write this as Q1 hat divided by N1 plus P2 hat Q2 hat divided by N2.
That's P1 hat times Q1 hat?
Yeah, I probably should put a times in there. So that's easier to read. Okay, so that's the equation you're going to use. Okay, so we're going to need to do our lower, we're going to need to do our upper. Now, we probably ought to figure out what everything is, right? What's P1 hat? P1 hat Q, well, that's good enough. Z sub alpha over 2. We're going to need P2 hat, and N1 and N2 are the same. So we don't need to worry about that. Okay, what's P1 hat?
They're not the same, they're 100 people off.
You're at 1608 and 1508.
Oh,
It should both be 1508.
they should both be 1508. I typed it wrong. Okay, now they're the same. All right. So what's P1 hat? 1086 divided by 1508. 1508. And what's P2 hat? 618 divided by 1508. Now, in real life, I would be shocked that those are the same. I wonder if they made that up. But your Z sub alpha over 2. How do you find that if you're not looking at your chart? Normus inverse. What do I put in for the probability? We're doing a 90% confidence interval, so I put in 0.05. Well, let me see. Yeah, you might want to put in, let me make sure. Yeah, that's negative, and then the 0.95 should be positive. Probably better with the positive, okay? Because, if you want to draw your picture, that will help you out. If you want a 90% confidence interval here, you got 5% in each tail. Okay? So that can be very helpful to you.
So why would you put 0.95 in there?
Because you want 95% to the left.
Oh.
Right? Okay? That's where the picture comes in handy. Okay? All right, so now your lower is going to be P1 hat minus P2 hat minus Z sub alpha over 2 times the square root of P1 hat, and we're going to need parentheses here, P1 hat times 1 minus P1 hat divided by N1, which is 1508, plus P2 hat times, oops, here I need parentheses,
What's Q1 hat?
1 minus P1. Parentheses, that's what I'm looking for. Now, when you do it all in one thing, this is a really great place to screw it up without knowing what you did. But that times 1 minus that divided by 1508. And hopefully I typed it right. I hope so. Yeah, okay, I think I did that right. But the other point of this is, okay, so now I'm going to put plus right here. And in fact, maybe I should put these in parentheses just to be super safe. So what we're saying here, and so here's what you can do to check yourself. I'm pretty sure that's right. Oh, actually, it is correct. That's correct. Okay. Now, let's think about this. let's interpret this confidence interval, and I don't mean we're 95% confident, whatever. What I mean is there a significant difference between 2003 and 2010?
Difference of 0.05.
No. It's much larger than that 0.05. Okay, so we're going to do our first question. Based on the confidence interval, is there a significant difference between 2003 and 2010? Who says yes? 1, 2. Is that it? Just 2? Who says no, there's not a significant difference? 1. Wow, this is going to be a tough test. Okay, because this is really what I'm looking at. When I ask for this, this is what I'm looking for. I only got 3 raises of hands. The rest of you, who doesn't know? Okay. Okay, so here's what you're looking for in this case. So the idea here is, yes, there is a significant difference. Now, let's look at this for a minute. When we look at this, in 2003, 72% of the people said we made the right decision. In 2010, it was just 41%. Okay? The difference, if I just subtract that difference, that's a 32% difference. Okay? Now, the confidence interval is telling me the difference is between 28 and almost 34% difference. So absolutely, yes, it's dropped by about between 28 and 34%. If you eyeball those two numbers, it's about 32%. If you eyeball those two numbers, you're saying it's between 28 and 34%. So yes, support for the war has dropped between 28 and 34%. So that's a massive change in public opinion. It's not 5%, it's about 30% roughly. Chris?
So we're saying we're 90% confident that it's dropped.
The drop has dropped between 28 and 34%. Okay? Yes.
So if the difference between P1 hat and P2 hat was more like 20%, but we still had those same numbers, then would we say it was not significant?
Okay, so let me change this number right now to make it not significant. What if, and here's what I'm going to do. Here's what I'm going to do. I'm going to multiply this, the lower end, times -1. Okay, now this is, obviously you would never do this, but just to show you. Oh, sorry, this was the upper end. Whatever, doesn't matter. Okay, let's pretend that these are the numbers you came up with. Okay, based on this confidence interval, which is now completely incorrect, but based on what I've got here, is there a significant difference in opinion of the war? Who says yes, there is still a significant difference? 1, 2. Who says no, there is not a significant difference? 1, 2, 3, 4, 5, 6. Why is no is the correct answer? Why is no the correct answer now?
Because 0 is in.
Because 0 is in your interval. Okay? We're saying, oh, well, it's between negative 34% difference and positive 28% difference. I can't tell if there's a difference. Now, clearly, you have that kind of a difference. More than likely, it would be between negative, say, 0.05% and positive 10%. That would be more likely. In that case, you'd say there's not a significant difference in opinion because 0 is in the interval. Now, since we're on this topic, I do need to let you go. Let me ask you this. If I was doing a 1 proportion test and I said that, no, let's do the coin flip, okay? The coin flip is P equals 0.5. The alternative is P does not equal 0.5, okay? I get a confidence interval. The lower is 0.0, 0.4. The upper is 0.6. This is my confidence interval. I do all the calculations properly. Okay? Is there a... Okay, so the null hypothesis is the coin is fair. You've got this interval here. Does this interval here tell you that the coin is fair?
Yes.
Yes, because
0.5.
Because 0.5 is in your interval. Okay, there's not a significant difference. You didn't even get to do the hypothesis, but this is actually a really good idea. Okay, so make sure you can understand what those mean. Yeah. Okay.
What are the exact chapters?
Chapter 11 and 12.
All of 11.
Pretty much all of 11 and all of 12. Okay, so good luck if you're taking it today. Class and test tomorrow. The written test is tomorrow in class. See y'all tomorrow.
So you said you get 11.